हाय स्टूडेंट्स, मैं विकास अग्रवाल आपके सामने आया हूँ पाथफाइंडर के क्वेश्चंस को डिस्कस करने के लिए। तो बिना कोई टाइम वेस्ट किए लेट्स स्टार्ट। तो पाथफाइंडर का जो फर्स्ट चैप्टर है काइनेमेटिक्स, ये उसके क्वेश्चंस है। लेट्स सी हाउ वी आर गोइंग टू सॉल्व दिस क्वेश्चन। सो द फर्स्ट क्वेश्चन सेज फ्रॉम अ टाउन कार स्टार्ट एट रेगुलर इंटरवल्स ऑफ 30 seconds and run towards another town with a constant speed of 60 km/h. At some point of time, all the cars simultaneously have to reduce their speeds to 40 km/h due to bad weather conditions. What will be the time interval between the arrivals of the car at the second town? So let's try to understand what is happening in this question. In this question, let's say this is town A, or let's say the town has not been named. Let us name that town as A, and very far away there is another town B. Okay. Now the question says that from town A, cars have been leaving at a regular interval of 30 seconds. Let me call this interval as T1. Okay, let me call this interval as T1. So and the cars are running with a speed of 60 km/h. Let me call this as V1. Okay, so let's say if one of the car has just now left, then the car that left before that, okay, would be at a distance of V1 into T1, and similarly the car that left before this particular car would be again at a distance of V1 into T1, and similarly other car will also be at a distance of V1 into T1. So basically, if I keep marking the cars which are still en route, okay, then the distance between two successive cars, okay, that will be V1 into T1. Okay, so we understand this part now, that as the cars are plying on the road, the distance between two consecutive cars is V1 into T1. All right, now let's say due to bad weather conditions, all these cars have now started moving with a different velocity, which is V2. So what we are suggesting now is that this car, okay, this car and so on, all these cars are now moving with a speed V2. They are all moving with a speed V2. Okay, so consider this, that again let me draw one more car. Let's say this is again moving with V2. So one of the car has just reached station B. So let me call this time as t equal to 0. I want to know that what will be the time when the next car will reach the station B. Okay, given that the bad weather condition have slowed them down, so we don't expect them to reach town B with a time interval of 30 seconds. We want to know what that interval would be. So if one of the car has just reached, and let me call that as t equal to 0, the next car which is at a distance of V1 T1, okay, will reach this after a time which will be given by V1 T1 divided by V2. Check this. This is going to be our answer. Like, this is the distance that this car has to cover. Once this car covers this distance, it reaches the town, and whatever time it takes to cover this distance V1 T1, that is the time gap between the arrival of these two cars. So that time gap would be given by V1 T1 divided by V2. So it becomes, V1 is how much? V1 is 60, T1 is 30 seconds, and then V2 is in the same unit as V1. V2 is also given in km/h. So the units get cancelled, so I'm not writing the units therefore. So it becomes 3/2 times of 30, which is 45 seconds. So 45 seconds is going to be our answer. That is option D will be our answer for this question. Alright, getting this, guys? So I would say not a very complicated question. If you understand the situation well, then it was an easy question to deal with. Now, next question. Sam used to walk to school every morning, and it takes 20 minutes. On his way, he realized that he has forgotten his homework notebook. He knew that if he continued walking to the school at the same speed, he would be there in 8 minutes before the bell. So he went back home for the notebook and arrived at school 10 minutes after the bell. If he walked all the way with his usual speed, what is the fraction of the okay, so let's do this. Let's say this is his home. This is home of Sam, and let's say this is school of Sam. Now the question says that it takes him 20 minutes to walk from home to school, which basically tells us that this distance can be written as 20 into V. Okay, this distance, I'm writing this distance as D. This is the distance between the home of Sam and his school. We can write it as 20 into V, where V is the speed with which Sam walks. 20 minutes. Okay, so the time here is given in minute. Now The question says that on one fine day he left his home, and while he was en route to his school, he realized that he has forgotten his homework notebook and he went back. Okay, question says that if he continued walking to school at the same speed, he would be there 8 minutes before the bell. He would be there. So let's say that the bell rings at time t. Okay, let's say t is the time when the bell rings. Let it be 8 a.m. in the morning. So, you know, just t is the time at which the bell rings. And let's say, according to what is written here, if he continued to walk to school, he would be there 8 minutes before the bell. Okay, it takes him 20 minutes and he would reach 8 minutes sooner. That means he probably started from home at a time which is t minus 28 minutes. Check this. This is the start time. This is the time when Sam started, because if he's starting at t minus 28 minutes, it will take him 20 minutes to reach the school, which basically means that he will arrive 8 minutes earlier than the bell rings. Okay, so that's what we know. Now, let's say he walked till eta fraction. We want to know the fraction. Okay, we want to know the fraction of the way. So he walked till a distance eta d. Okay, he walked till a distance like this. He came like this, and so he left at this time. Okay, so let me do the math now. This is the start time. He started at this time, then he traveled eta d distance with a speed v. So the time he would have taken would be eta d by v. This is the time he would have taken. Then he went back the same distance, so I will double it, and then he came to school, which would have taken another 20 minutes, and he realized that he was 10 minutes late. That means the time at that time would be t plus 10 minutes. Check this equation. If you have written this equation, you are almost done. Like, the question is almost over. This is the time when he started from home. Then he traveled to a point. Then he went back. I have added that. Plus 20 minutes of traveling to school again is equals to t plus 10. So this t gets cancelled. We have to do the math now. Okay, so this minus 28 plus 20 will become minus 8. I'll bring the minus 8 here. It will become 18 minutes. Okay, so I'll do the math on the next page now. So 2 eta d by v. Okay, 2 eta d by v is equals to 18. Is equals to 18 minutes. Okay, and d can be written as 20 into v. Remember, this 20 was in minutes. Okay, this 20 was in minutes, so basically this 18 is also in minutes, so minutes gets cancelled, v gets cancelled. So eta is what? Eta is 18 by 40, which is like 9 by 20, which is what we wanted to get. Okay, so 9 by 20 is present in one of the options, and that is the correct answer. Alright, I hope you got this question, everyone. Let's go to the next one. So now the question says that there are 3 particles A, B, C, and they start moving simultaneously with a constant velocity from 3 places. The starting places are collinear, and that of B is somewhere in between those of A and C. Okay, so let me first draw the situation. So if I draw, let's say, a straight line like this, okay, then I can say that probably A is somewhere here. Okay, A is somewhere here. C may be somewhere here, and B would be anywhere in between A and C. We are not saying that it is midway between A and C. It is anywhere between A and C. Okay, now what does the question says? It says that in the absence of C, particles A and B would have collided in time t1 after they started. Okay, so pay attention to this. The question says that they are moving with constant velocities. This basically tells us that all the 3 particles will move on a straight line. So trajectory of each particle is going to be a straight line. Okay, and the question also says that in the absence of C, particles A and B would have collided in time t1. So let's forget C. If A and B were to collide, then suppose A is moving on this straight line. Let me change the color. So let's say A is moving on this straight line. Okay, then the trajectory of B has to intersect this, because otherwise collision is not possible. So let's say the trajectory of B was somewhat like this. Okay, so this is the point where A and B are going to collide. So this collision will happen at time t1. So A will be present here after time t1, B will be present here after time t1. Okay, and we can say that A is traveling maybe with a speed of v1, B is traveling with a speed of maybe v2. Okay, so till now the question tells us that if C, in the absence of C, particles A and B would have collided t1 time after they started, and in the absence of B, particles A and C would have collided t2 time after they started. So if B wasn't there, so let's forget B, ignore this line, so C would have collided with A. Okay, now let me think over this, and you should also think over this. If I tell you that under what conditions C will not collide with A, so there are chances if C goes in that direction, like if C goes in that direction, so if C goes in anywhere in this region, it will not collide, that is for sure. Okay, or at least it's that is for sure, it's the collision, there are no chances of colliding. Okay, if any possibility of collision has to happen, then C must come to in the downward direction. Okay, and then also it's not confirmed that collision is going to take place. Okay, also let's say if I draw a line parallel to the trajectory of A. Okay, if I draw a line parallel to the trajectory of A, so if C goes anywhere in this region, then also the collision will not happen. So C is definitely not going into this region. Okay, we are very sure that C is not going into this region, otherwise collision would, the collision of between A and C will never happen, but the question says that it happened. Okay, so C is definitely not going here. So C is going somewhere in this direction, like somewhere in this angle C is going, right? And even this angle can be split into two regions. Those two regions would be like if I join this point and this point. Okay, so there are there is a possibility that C is going in this direction, like this could be the possible trajectory of C, or C may be going in this direction, this could be a possible trajectory of C. Okay, so there are three different trajectories I have made. Let's say this is X, this is Y, this is Z. Okay, trajectory Y would mean that C collides with A at this particular point, and A was present here at time t1. So it basically means that C collides with A at time t1, which basically means that t1 is equals to t2, because t2 was the time when A and C collides. Okay, t2 after time, it is A and C would have collided after time t2. So collision between A and B happens after time t1, collision between A and C happens after time t2. So if at all C went on the trajectory Y, then it would mean that t1 is equals to t2. In case if C goes on the trajectory X, okay, then C will meet A here. Okay, C will meet A here, and A would be present here before it is present here. So it basically means that on this trajectory, on this particular trajectory, T2 has to be less than T1. Okay, on this particular trajectory, T2 has to be less than T1. And similarly, if C collides with A when it is moving along Z trajectory, then C collides with A at this point. A will be present at this point after it has crossed this point. So this means that T2 would be greater than T1. So if T2 is greater than T1, then Z trajectory is applicable. If T2 is less than T1, then this X trajectory is applicable. If T2 is equal to T2, if T1 is equal to T2, then Y trajectory is applicable. Now let's read the options. Okay, so question says that if T2 is greater than T1, so we are talking about which trajectory? If T2 is greater than T1, we are talking about the Z trajectory. Okay, particles B and C may or may not collide. Okay, now what we have drawn currently, we see that B and C, yes, there are chances of them colliding. Okay, so there are chances of them colliding if T2 is greater than T1. Okay, B and C may, so it may collide. What about may not? So if I draw a trajectory parallel to B, okay, like if I draw a trajectory like this line is, let's say, parallel to the trajectory of B. So if C goes anywhere in this region, like between this dotted line and between this green line, if C goes anywhere in this region, C will collide with A, and T2 will be more than T1, but the collision with B will not happen. Okay, if C goes anywhere in this region, like anywhere beyond this line in this region, then collision with B will not happen. So yes, there are chances. If it goes on the trajectory Z, then it may collide with B. If it goes on this trajectory, then it may not collide with B. Okay, so if T2 is greater than T1, particles B and C may or may not collide. Yes, we agree with this. If T2 is more than T1, particles B and C collide in the time interval T1, T2. So if T2 is more than T1, okay, if T2 is more than T1, so this kind of trajectory, so the collision between B and C will happen after T2. Okay, we can see that this trajectory meets the trajectory of B at a later instant after T2. Okay, so if T2 is more than T1, it collides in the interval. This is wrong. Okay, if T2 is less than T1, now less than equal to, now we are discussing these two trajectories. Okay, if T2 is less than T1, particles B and C may collide at a time which is less than T2. So if either of these trajectories followed, we can see that C intersects with B here. Okay, and C will reach at this point at T2, so this time must be earlier than T2. So yes, T2 has to be less than T has to be less than T2 then. So B and C may collide at instant. So yeah, this is correct. Okay, and it says that if T2 is less than T1, B and C may collide in the interval. So I think this is wrong in itself. It says if T2 is less than T1, that means T1 is greater. Then how can we talk about the interval T1 to T2? And in any case, we have already figured out that if T2 is less than T1, then the collision of B and C, which happens, let's say at time T, will happen before T2. Okay, so we can clearly see that T is outside the interval T2 and T1. Okay, so this is definitely wrong. So the correct options here are A and C. Let's have a look. So A and C options are the correct ones. So I hope you got this question. So this question was totally devoid of mathematics, but good logic was needed to be applied in this question. Okay, let's go to next question now. So question number 4. A particle moving continuously in the positive x direction passes through positions 9 and 7. So let's say a particle is moving on the straight line, and this is position x equals to 9 meters. Okay, and this is position x equals to 17 meter. Let's say this is the case. Okay, it is present here at t equal to 1 second, and it is present here at t equal to 3 seconds. Now notice that to calculate the average speed or average velocity, we only need these information. Like we know that the particle was here at some time, the particle was here at a later time. So the average velocity, okay, for this interval will be given by 17 minus 9 divided by the time interval, which is 3 minus 1. So it will become 8 by 2. So the average velocity is 4 meter per second. We know this. Now the question says that the same average velocity was applicable for a time interval which encompasses this time interval. Like the particle may have been somewhere here, okay, at t equal to 0. The particle may have been somewhere here at t equal to 6 seconds. We know that from this position to this position, the average velocity was same as 4 meter per second. Okay, so then we have to make some conclusions. So guys, this information that from 0 to 6 the average velocity was 4, what it tells us is that this length is 24 meter. It tells us that. Okay, but apart from that, it doesn't tell us anything. For example, consider a rod of 24 meter that I'm holding. I can shift it back and forth. Okay, I can shift it back and forth so that this end remains somewhere in this region and this end remains somewhere in this region. Are you understanding? Imagine a rod of length 24 meter. It can be shifted such that one end remains before 9 meters and the other end remains after 17 meters. Yeah, after 17 meters. Okay, so long as we are keeping the two ends outside this 9 to 17 interval, okay, the conditions will be met. What conditions? That the average velocity from 0 to 6 is same as the average velocity from 1 to 3. This condition will be met. So what I'm trying to suggest is that we are not in a position to comment that where was the particle at t equal to 0 or where will be the particle at t equal to 6, and therefore we can't even calculate the average velocity between these two times, because this distance is again not fixed, it can change. Okay, so it was at x equals to 5, not necessary. If it would have been, it may have been at x equals to 5, yes, that could have been a possibility, but that's not a necessity that it should be at x equals to 5. No, wrong. It is moving with a uniform speed. Again, we can't be sure of this. Okay, average velocity in the interval 3 to 6. So again, I can't comment on the average velocity between 3 to 6 because I know where the particle was at 3 seconds, but I don't know where the particle was at after 6 seconds. So I cannot calculate this displacement and therefore I cannot comment on the average velocity. So information is insufficient to decide any of the above. So that part is true. Yes, we cannot draw any of the above conclusion, and therefore option D would be the correct one. All right. Okay, so the correct answer here would be option D. Okay. Now going to the next question. Question number 5, it says when a car passes mark A, driver applies brake and thereafter reducing the speed uniformly. It's a important word here. Thereby reducing the speed uniformly from 160 km per hour. At A, the car passes mark C with a speed of 40 km per hour. Okay, the marks are at equal distances on the road. So these distances are equal. So if this distance is D, okay, then this distance is also equal to D. Okay, so where on the road was the car moving with a speed of 100 km per hour? Okay, all right. So the best way to solve such questions is to think about the VT diagram. Okay, let's talk about the VT diagram. Okay, so if I have to draw VT diagram in this case, I will draw a diagram like this. Okay, because the speed is uniformly decreasing, therefore the VT diagram will have a constant slope. The starting value will be 160, okay, kilometer per hour. Okay, and this value will be 40 kilometer per hour. Okay, now notice that 100 kilometer per hour is the mid value. It's the average of these two. It's exactly midway. So at the middle point, if I draw a horizontal line, okay, at the middle point, if we draw a horizontal line, if this is 100, okay, notice that because this will be the midpoint of this, so this length and this length will be equal. So we are very sure that this area, okay, this area indicates the AB distance, and this area we are very sure that they are not equal. Rather, AB is more than BC. Are you getting this? This area indicates the distance, the displacement in the time interval when the speed drops from 160 to 100. So that is more. Okay, so therefore B point is certainly closer to C. Rather, I shouldn't say B point. Oh, okay, I shouldn't say B point was given to be midway. I should talk about a point D. Okay, I should talk about a point D. Instead of B, I should say that AD. D is which point? D is the point where the speed became 100. Okay, so AD is definitely more than DC. Okay, so D point is closer to C. Okay, so it means that D is somewhere here. Okay, so between mark B and C, that is the correct answer. Is that okay, everyone? Okay.